Alright, this is 5.4, part 2, and we're going to be talking about how to convert our logarithms from individual logarithms to pulling them apart so that they are individual pieces. And we're going to start with our a here, which is log base a, with the fraction of x squared times y to the fifth all over z to the fourth. So here's our original problem, and we're going to go ahead and I'm going to pull it apart so that it's the numerator and the denominator, because that way it's real clear, the distinction is real clear between them. And now I can go ahead and deal with the multiplication piece. So we've dealt with the log base a x squared, and then we say plus log base a y to the fifth, because those two were being multiplied. And then we're going to subtract log base a z to the fourth. Now that z to the fourth was in the denominator, so it's a subtraction piece. We're going to do the one last thing. We're going to go ahead and bring our exponents down in front of our logs. We have a 2 log base a x, a 5 log base a y, and a 4 log base a z. So we're going to add the first two, the x and the y, and then we're going to subtract that last one with the z. Alright, our next one we're going to look at is going to be log base a cube root. We're going to have an a squared times b, all being divided by c to the fifth. Alright, so here's our initial starting place. Alright, so we're going to take a moment and think that cube root is the same as multiplying something, raising something to the 1/3 power. Alright, so we've got log base a, and then we've got this part that was a fraction, and then that's all being raised to the 1/3. We're going to bring the 1/3 down. So you have 1/3 log base a squared b divided by c to the fifth. Alright, so we take our 1/3, I'm going to pull it all apart, right? I'm taking apart my fraction first. I've got my log base a squared, b minus log base a, c to the fifth. That whole thing, we're going to take the 1/3 of that. So the next thing I'm going to do is I'm going to bring down all of my exponents so that they're in front of the logs, and I'm going to pull apart my multiplication piece. So here I'm going to have a 2 log base a, and I'm going to add that to log base a, b, and subtract 5 log base a, c. Alright. Now, something kind of magical happened here from one step to the next. If you take a look, the very first term, we have log base a, and we had a 2 down in front of it, and then all of a sudden we just have a 2. Well, what happened? Remember, we're dealing in exponents, so if I have a raised to the first power, I get an a, right? So here's the a, this a is here, and then this is my base, right? So those two are telling me that's a 1. My exponent on that is a 1. So I'm multiplying 2 times 1, which is just plain old 2. Alright, so that's a little mind-blowing the first time you see it, but it's kind of cool. That's one of the reasons why I've been belaboring the point about a to the 0 is always a 1, and a to the 1 is always going to be that original value back, our a, right? So now we're going to go ahead, we're going to multiply through by 1/3. So I have 2/3 plus 1/3 log base a, b, minus 5/3 log base a, c. Alright, in our last one here, we're going to have a log base b, and we're dividing a, y to the fifth by the quantity of m to the third, n to the fourth. Alright, we're going to pull these apart. Again, I'm going to do the division piece first, and then we'll address the multiplication piece. All right, so here's our numerator subtracted by our denominator. That all looks good. We know that that was a subtraction. This piece here, we're going to have to keep this whole thing inside parentheses because we're going to have two pieces now, and that subtraction is multiplying all the way through. So keeping that in mind, here's our log base b a, and then I'm going to add that to my log base b y to the fifth, right? That's my numerator. And then I'm subtracting my log base b m to the third plus my log base b n to the fourth. Now I'm going to multiply through with that negative. So I've got log base b a plus log base b y to the fifth minus log base b m to the third minus log base b n to the fourth. All right, the last step here is we're going to pull our exponents down in front, right? And at this point, there was nothing left for us to combine. We had it all done. So this is our final answer on this one. All right, so here we're going to take this and we're going to work it backwards. We're going to go from several different pieces and smush it all into one logarithm. So kind of working our way backwards, we're going to take a look at our values down in front. So we have a 5 log base bx, so that's going to become a log base bx to the fifth. This is a negative, so that's going to be a division problem, right? So I've got my log base by, that's all going to be in the denominator. And then this is multiplying, so I've got this is in my numerator again. So I have a log base b z to the 1/4, or to the cube root, or fourth root, I mean. All right, let's take a look and see what happens when we do this here. So there's our original. We're going to go ahead and take a look at that. We've got our exponents raised back up the way we wanted. Now we're going to have we have our fraction started. We have the x to the fifth over the y, and then I have this plus log base b z to the 1/4. I'm going to, again, that becomes a multiplication piece. So I've got this whole thing. I've got 5 to the x, z to the 1/4, all of that over my y, and we're using the log base b. You could also have written this log base b x to the fifth, fourth root z, all over y. Okay? All right, so here we're being told what we have as actual values. We're being told log base a 2 is about 3.301, and log base a 3 is 0.477. So in that case, we're going to have to think about what's happening, and we're actually going to plug in numbers at some point. So here we go. So taking a look at log base a 6. Well, 6 is the same as a 2 times 3. So let's go ahead and think about that. So our log base a 6 becomes log base a 2 times 3, which we can again pull apart. So it becomes log base a 2 plus log base a 3. And now we're going to substitute those values in, and we'll go to 0.778. All right. So again, we're going to do the same thing with our b term, and in this case, we're going to have that 2 in the numerator and the 3 in the denominator. And we're going to go ahead and, once we've got that sorted, we're going to go ahead and actually do the arithmetic around that. All right, log base a 2 over 3 becomes log base a 2 minus log base a 3. And then that just becomes a simple subtraction problem. And we get a negative 0.176. All right, we're at about 10 minutes. I'm going to stop here and we'll pick up on part 3.